So hi everyone, this is Nikhil, and in today's video we are going to see how you can design a small Formula 1 car toy and how you can 3D print it. So in the previous video I have just shown you a brief overview of how the F1 car looks like. So I will just show you how it is designed and we'll try to design something similar. So let me open this model for you. So basically any 3D design software supports 3D printing. You have to convert that file into .stl file format, and currently I'm using Autodesk Fusion 360, but you can use either CATIA or SolidWorks or PTC Creo or Autodesk Inventor or any other CAD software. You can also use Siemens NX, but after you have designed the CAD model, you need to export that file into .stl format, and then you can import that file into any slicing software like Ultimaker, Cura, and then you can set up various 3D printing parameters. For example, if you are trying to 3D print it using FDM technology, you need to slice it and convert the file into a G code. Or if you are trying to 3D print it using stereolithography or powder bed fusion or selective laser sintering or any other similar technologies, then those technologies will have their own dedicated software. It looks similar to a slicing software, but it has its own parameters. For example, if you are using SLS, that is selective laser sintering, that is the company which is currently used in is EOS. EOS is a company which manufactures powder bed fusion based 3D printers. So they will have their own software. So such softwares are generally not available for free because they come only with the machine. So like if you are a manufacturer trying to manufacture any of the model, then at the time of purchasing the machine, it comes with its own dedicated proprietary slicing software come parameter setting software, from which you can import the 3D model into it and you can 3D print it. So what you're seeing here on the screen is a 2007 style Formula 1 racing car. So it took me about 5 to 10 days to design, and you can say roughly I spent around 50 hours to design this part. So you can see various CAD design operations on the history timeline here. So it's relatively considerable amount of design work that goes, and several of you have commented in some of the previous videos that which CAD software is more preferable, and I would suggest that depending on the industry, specific industry will be using specific CAD software. For example, if it is an aerospace company or an automobile sheet metal design company, they will be using CATIA surfacing because CATIA is very good for surface modeling. Companies like Boeing, Airbus, Toyota, Mitsubishi, these type of companies use CATIA, and typical CNC machining, any company which is involved in CNC machining will be using SolidWorks, and any company which is involved in plastic injection molding or plastic part manufacturing typically uses Siemens NX. And Fusion 360 is relatively new into the market because it launched, I think the first version was launched in 2014. So it's a cloud based software, and the reason why I am using Fusion is because it is free for students and educators, and it's basically offering some advanced features like generative design, which is also free of cost for students and educators. We'll make dedicated generative design videos later. So that's one of the reason why I'm using Fusion 360. But I'm not telling that this is the only software which is available in the market. You can use any software which suits your needs. And so basically, I started off this design by importing an image. So you can import a background image called canvases, and you can see that If I turn off the model and if I turn off all the components, I'll simply hide them all, and you can see that there is a background image. One is the front view, another is the top view. This is basically a 2007 style Ferrari F 2007 image. So it's available to download for free. You can just Google it. So any major automobile or aeroplane has its own blueprint. So you should use a keyword called blueprint when you are trying to search on Google. I'll give you a small demo. So if you type something like this, you will get various images. That's known as blueprint. You can simply right click and you can simply say save image as, and you can simply save that image and you can import them. And generally any image like this are subject to copyright, but what I would advise you is that if you are using it for education purpose and if you are using it for learning purpose, then you can stay away from corporate risks of getting sued. So like I received some of the LinkedIn comments stating that if I'm using a direct CAD model or a direct image of Ferrari, I am at a risk of being sued by Ferrari themselves. But I am okay with it because getting Ferrari's attention is much more important for me than uh, like trying to stay away from them. So I am going with my own risks. And generally, what you can do is actually as I'm trying to manufacture these toys, so there is something known as a manufacturer's license wherein you can download the exact CAD model of Ferrari car itself and scale it down and manufacture it, paste the logos and get Ferrari's approval. And with the license of Ferrari, you can actually market the Ferrari merchandise. So one such company called NewRay Toys actually manufactures such scaled down die casted injection molded toys. So typically, those toys are manufactured mainly in China and Hong Kong because they have cheap labor, cheap resources, and materials. But as India is mainly focusing on Aatmanirbharbharat and Make in India, we are one of the company which is pioneering in manufacturing of toys. So we have our own brand name called ProtoPrix, wherein we primarily manufacture 3D printed race car toys. And so after you download the image, you can simply import it into Autodesk Fusion and you can put it as a canvas. So under the inspect or insert element, under the insert element, you have an option called canvas. You can click on it. So you can simply import the image, or you can simply insert from your computer, or you can just browse it and you can click on insert. For example, if I'm trying this image for I'll just show you for a small demo. It will ask you to select a face or a plane. So maybe if I'll just pick up this particular plane, I click on front view, you can see that the image is now displayed here. You can move it around to the desired location and you can hit OK. And after you hit OK, you have to again right click on the canvas and say calibrate. And typically you can find the length of each car on internet. So the Ferrari F 2007 has a length of around 4525 millimeters. So what I'll do is I will scale it down by 100 times and then scale it up as per my need. So as I'm not designing a full scale F1 car and I'm trying to design a toy, what I'll do is I will just pick up the length of the maximum extreme points of the front end and the back end of the car, and it will ask you to give a dimension. So 4525 divided by 100 is roughly around 45.25 millimeters. So I will type 45.25 here. And now you can see that it is scaled accordingly. And now you can see that this is image. So actually I downloaded only the front and top views, and I have not yet downloaded the front view. So if you happen to download it, you can place it. And for me, like the front and top view are enough to design the car, as I'm not trying to replicate the Ferrari car inch by inch and millimeter by millimeter. I just wanted a rough blueprint so that I can design my own car. And you can change the opacity so that whatever the sketch you are drawing on top of this car will be visible to you. You can hide it at any time or show it at any time. And after you draw the sketch, for example, I will just show you some of the sketches I just drew. I will click on edit sketch and try to show you what I have done. So you can see that on top of the sketch I drew these wheels, and you can see that the rear wheel is not currently aligned. That is intentionally made because whatever the picture I have downloaded is in perspective view. So in perspective view, whatever the view which you are seeing is slightly zoomed in. So that's the reason it is creating a view or an image which is slightly having more length than the photograph itself. So like after you have finished the sketch, you can give appropriate dimensions. I have rounded the nearest dimension, and then you can click on finish sketch, and that's how I have developed this car. So and then later I have scaled it up to 4 times. So scale it down by 100 times and then scale up by 4 times will give me a model which is 1:25 scale. So roughly the size of this toy has a size of 200 in length. And I will turn on all the components. And one more feature I wanted to show you is the MechMaster CAD library inside of Fusion. So for example, I have imported the models of this screw. You can see the screw which attaches the wheel to the hub. So this particular screw is a M2.5 millimeter metric ISO thread screw with Phillips head. So Fusion 360 allows you to import MechMaster CAD library directly into the working environment. So to do so, you can simply go to insert again, insert menu, and you can click on MechMaster CAD component, and it will open up a library like this. And inside this library, you click on screws and bolts, and here select metric, and here select the size you need, 2.5 mm, and then select the length. I needed 8 mm, and inside I needed oval Phillips head, and once I'm okay with it, I can simply click on this number, after you click on that, it will be showing like this 3D models. You can select step file and click on download, and now you can see that that particular screw is now imported into Fusion 360. You can move it around using the arrows to whatever the location you need, and you can simply hit OK. And after the model is imported, you can again right click on that particular model and click on move or copy, and you can rotate it to the orientation you want. And you can hit on OK, and that's one of the advantage. So such feature is also there in SolidWorks. I don't know its feature name. Let me know in the comments. So SolidWorks also allows you to download CAD models like that. And after you're finished, you can simply go to file and go to export, and you can export the files into .stl format and click on export. And as this model is having multiple bodies, you can also export individual bodies so that you can select the 3D printed parameters individually for each and every component. So for example, I only want to export the STL file of this particular body. I can simply right click on it and save as mesh, and it will ask you to select a few options. You should use STL binary, and units should be in millimeters. Refinement, typically I would advise you to go for medium. Medium is mostly suited for most of the applications, and I recommend high if you have extremely erroneous surfaces, or otherwise medium is relatively good and decent enough. And I'm not going into all the details of refinement options, they are auto selected. And once all this done, you can simply click on OK. It will ask you to save that file STL. You can simply give it a name, and you can simply save it. And you can 3D print them by importing into Ultimaker Cura. To know detailed videos on Ultimaker Cura, I uploaded one video earlier in the channel. You can go and watch it. If you are new to Ultimaker Cura, the video contains how to download and install Ultimaker Cura and the basic settings you need. And once all the settings are done, you can simply slice the model and save to disk. It will export a G code format, and you can copy that G code into an SD card and place it in your 3D printer, and you can start printing. So if you're interested in purchasing this toy, you can order it from our website. And in the next video, I will be discussing on dimensionals and tolerances required for manufacturing this toy, and some of the design for ready to manufacturing constraints that I used to individually split. For example, you can see that the rear wing is separate from the main chassis, and the reason for it is if you're trying to 3D print it in a single piece, the rear wing is in the middle of air, and if there is any geometry that is overhanging in air, you would need supports. And if you are 3D printing supports for that geometry, it will create some weak sections in the geometry, or it can create rough surfaces, and the finish will not be perfect. So that's the reason I have split the chassis from the rear wing. So if I simply hide the rear wing once again, you can see that there is a slot. Inside this slot, the rear wing gets seated. And I'll try to hide one of the tires to show you how it works. You can see that there is a hole. You can see that there is an internal cavity that is running all throughout from left to right. So you will insert the CNC machined axle inside this hole, and you should make sure that whatever the CNC machined axle is there, it is perfectly cylindrical in shape, the axis is perfectly straight, and the surface finish is at least 3.2 to 6.4 micrometers in surface roughness terms, so that the wheel will have very less friction when it is rolling on the floor or when you are trying to play with it. So the disadvantage of 3D printing is that you will not get extremely good surface finish, and even if you try to polish it, you cannot get a perfectly circular or a cylindrical shape. That's one of the reason why we have to go for CNC machining. So this axle will be CNC machined at one of our partners, and we will assemble all of them, and that's how toys like these are made. And coming to the aerodynamics, one disclaimer I would like to share is that this model toy is not perfectly aerodynamic. It is not tested in the wind tunnel, or it is not tested in CFD. And to make the model more aerodynamic friendly, we need to analyze it. So I will make separate playlist on how you can do CFD analysis using ANSYS Fluent. And in our college, we are developing a facility called water tunnel, wherein you can place the 3D printed F1 car model and allow the water to flow around it, and you can inject a color dye into the flowing water, and you can see how the water is flowing. And the reason why we chose water instead of air is because water is more denser, and hence you can maintain the Reynolds number similarity between the actual F1 car and the model car. So water is about 800 times more denser than air. So that's why we are trying to develop a water tunnel so that we can test model F1 cars like this. Such a facility is very rare. I saw one video on YouTube wherein I think that's a university somewhere in Canada. I don't remember the university name. It's somewhere in Montreal or Toronto. So that university has a water tunnel to place 3D printed automobiles, and they have a facility called as electrostatic bubble generator. So it has an electrode in the flowing water. It generates electricity through which the surface will get activated and energized, which will generate hydrogen or oxygen bubbles. So those bubbles will travel down the water, and you will be able to see how the water is flowing around the air, around the model. And that's one way to visualize the flow. So to develop such a facility, it would require a cost of anywhere between 5 lakhs to 10 lakhs, and affording that much of amount to test a toy is not feasible, and hence we are analyzing it using colored dye. So it's relatively cheap, and you can analyze as a beginner level, and once you get sufficient confidence, and what you can do is you can scale up the model and send your model to a large scale wind tunnel. Typically for academic research, I think IIT Bombay and IIT Madras have a wind tunnel. You can place your 3D printed F1 car there and analyze for the downforce and drag, and you can not only analyze the complete body, but you can also place sections. For example, if you wanted to analyze the CFD flow of a particular component like a front wing or only simple element. For example, if you wanted to analyze how this barge board will channelize the flow around the front wing and deflect it some portion under the floor and inside the side ports. So such analysis you can do inside wind tunnels, and you can also analyze it using CFD called like the majority of the F1 teams use ANSYS Fluent as well as Star CCM Plus for CFD analysis, and typically they will use around 10 million to 100 million cells, and to run such CFD simulations would require a high performance computing cluster. And India has world's fourth fastest supercomputer or HPC, you can call it. That's there in TCS. So, like previously, it was a government organization called as Computational Research Laboratories, and that lab was acquired by TCS for like for various biomedical applications. And one of their client was Ferrari. So they have done CVT analysis for Ferrari between 2006 to 2011 roughly, and I'm not sure whether that contract is still active or not. But if you don't have access to that high performance computing cluster, you can also use cloud based computing softwares like SimScale, for example, and you can also use Amazon AWS inside of ANSYS Fluent. So currently, the ANSYS Fluent that is capable of running inside Amazon AWS is only available for F1 teams, and it's not yet available for ordinary customers. But I really hope they will roll out that feature soon, so that students like you will be able to analyze CFD, and more about CFD will be shared in the upcoming video. So thank you for your patience and watching, and do give your suggestions and comments, and I will make sure I will answer them in the upcoming video.